All right, here we go. We got numbers 9 through 19 on the cumulative review number 4. All right. So, number 9, it says show algebraically if the following function is even, odd, or neither. You must show the step-by-step work for this problem, okay? Remember to test if it's even, odd, or neither. All right. If I want my function, if my function is even, if I plug in f of negative x, I will get my original. That's for even. If my function is odd, if I plug in f of negative x, I will get the opposite of f of x. Okay? So, my first test, f of negative x equals 2 times negative x quantity cubed plus negative x quantity squared equals. If I take a negative number to an odd power, my answer will always, my result will be negative. So 2x to the third. If I square a negative, my result will be positive. So this is negative 2. If I think about it like this, if I take out the negative 1, it'd be 2x cubed minus x squared. So this is not even because this isn't our original. This is not odd because it's not the opposite of our original. If it were the opposite of our original, this would be a plus x squared. So this one, number 9, should be neither. Okay? Next, number 10. Big question. Here we go. So, on what intervals is our function increasing? All right, remember, our function is increasing when our function is rising. So right here, I have a negative slope, so my function is falling. That's a decrease. It's increasing from here, this point, to that point. Remember, when we do increasing and decreasing, our intervals are using our x values. So from negative 2 to 0, use our x values. And then from 2 to infinity. Decreasing here, negative infinity to negative 2, union right here, 0 to 2. Remember, we use our x values for increasing and decreasing when we're writing our interval. Okay? What is the domain? Remember, domain is your x values, all your possible x values. Read my domain from left to right. Because this is going off to infinity, that means my x's are going to continue to get larger and larger, and so are my y's, my outputs. So my domain, no matter what number I input for x, I will always get an output for y. So negative infinity to infinity. My range, okay, remember range is read from bottom to top. All right, the first number I hit is here, negative 7. The last number I hit is unseen to infinity. Okay, negative 7 to infinity. All right. Next, name a relative maximum. If there is any, please use in sentence notation. All right. Well, relative maximum. Okay. Well, these 2 points would be minimums here. Okay. So a relative max. Remember, relative max is the maximum of all the points around it. So I'm going to look up here. That is 0, 9. All right, so we want to use sentence notation. At x equals 0, the relative max is 9, our y value. Okay, absolute minimum. All right, if any, please use sentence notation. Well, these 2 points here are the absolute minimums of our graph, right there. Okay, now, here's the deal. There's 2 of them, obviously, right? Well, I can write either one. Okay, I'm going to write them both out for you. At x equals negative 2. And I'm using shorthand notation. The absolute, you should write it out, min is 7. Or you can write at x equals positive 2. The absolute min is negative 7. That's supposed to be negative 7. My apologies. All right, so is negative 7. Either of those work. Okay, if this were a question on our test, if you wrote this one, you have that correct. If you wrote this one, you'd be correct as well. Okay, either of those options work. Is there an absolute maximum? Well, our function here goes off to infinity. This is considered a relative maximum because relative to the points around it, it is a maximum. However, there is no absolute because our graph goes on to infinity, is continuing to increase. So there is none because y goes to infinity. Because our y values are our range, or range goes to infinity. All right, our outputs. Okay, that's number 10. That's a great one. I like number 10. That's solid. All right, so what's next? Domain and range. Find domain and range. Remember, domain is from left to right. All right, if I'm looking at this function from left to right, the first x value I hit is -3. It's a hard close because this is a closed dot. -3 to 0. However, I pick it back up here. It keeps going and drops down here. So technically there's an input and an output for 0. There's an input and output for 1, even though there are holes here, but there's a closed dot here. So I'm going to continue all the way to 4, and since it's an open dot, it's a soft close. Do not put -3 to 0, union 0 to 1, union 1 to 4. This would be incorrect. Okay, that is incorrect. Don't make that mistake twice. Yikes. Okay, here we go. Range. Range, remember, is from bottom to top. All right, bottom to top. My smallest possible y value is -3. Closed dot, so I include it. Okay. -3 up to, I hit 0. Including, because it's a closed dot, there's this gap here. Don't forget the gap. Okay, since there's a gap here, I'm going to put union, pick it back up at 1 to 2. And there are 3 open dots actually here, so y does not, or, yeah. Okay, and we're back. All right, so, yeah, let's do number 12. Here we go. Number 12. All right, so remember with number 12, if I factor this as x plus 7, x minus 7. Okay, so I'm going to multiply my entire expression, my entire equation, by x plus 7, x minus 7, all over 1. Each individual fraction gets multiplied by that. I'm going to show this step. Okay, some of you may be able to skip it and do it in your head. All right, but I'm going to show it anyway. So this is going to be 3 times x plus 7, x minus 7, all over x minus 7, minus 30, just so you can see where this comes from again. Don't forget about this problem. Ooh. Okay, x times x plus 7, x minus 7, all over x plus 7. So as you can see, what starts to cancel out? X minus 7's cancel out here. Both cancel out there. X plus 7's cancel out there. So my first is 3 times x plus 7 minus 30 equals x times x minus 7. Distribute. 3x plus 21 minus 30 equals x squared minus 7x. Boom. Okay, remember you can always pause this, rewind it, and go back, okay, because you're having so much fun. All right, so now I see an x squared term I'm going to have to factor. All right, so I'm going to move all of these terms to the right side of my equal sign. So I'm going to do a couple steps in one here. I know this right here will give me -9. So again, I'll move everything to the other side. Okay, so I'm going to get 0 equals x squared minus 10x plus 9. Okay. Factors of 9, 3 and 3, 9 and 1. X minus 9, x minus 1. Set H factor equal to 0, zero product property. X equals, what the heck happened there? X equals 9, x equals 1. Check for extraneous solutions. Well, if I input 1 and 9 back in here, I will not get 0 on the bottom. Therefore, both answers work. 1 and 9. Here we go. 13. We're flying. We're having fun. Stop having so much fun. Oh, I'm going to sneeze. Bless me. Thank you. Okay, so to find the equation of a circle with the diameter, all right, these are my endpoints and my diameter. Remember, if you think about your circle, diameter goes straight through the center. All right. So that means that with the diameter, I have two congruent parts. Okay, so if I want to find the center, I need to find the midpoint. Remember your midpoint, add your x's and divide by 2. 7 plus 5 over 2. And add your y's. 1 plus negative 7 over 2. So my center, 7 plus 5 is 12. 12 over 2 is 6. 1 plus negative 7, negative 6. Negative 6 divided by 2, negative 3. Okay? So I have so far x minus 6 squared plus y plus 3 squared equals r squared. So I need to solve for r squared now. So I'm going to use, you can use either point. I'm just going to use, 7, 1, just because it's first. Okay? 7 minus 6 squared plus 1 plus 3 squared equals r squared. 7 minus 6 is 1 squared plus 4 squared. So that's 1 plus 16 equals r squared. So r squared is 17. Now don't make that unnecessary step of finding the square root. Okay, they'll just give you r, and then when you have your equation, you want r squared, so I might as well just leave it. All right, so my final answer is x minus 6 squared plus y plus 3 squared equals 17. Happy. Oh, happy day. All right, 14. All right, 14 arc length. Now remember we have this theta equals S over R, where theta is our angle in radians, S is the arc length, R is our radius. Well, our angle here is in degrees, so we need to put that into radians by multiplying by pi over 180. Remember, this is over 155 pi over 180, reduce, reuse, recycle, 11 pi over 36. Okay, so S is my arc length, so I'm looking for S equals theta times my radius. Well, here is my angle, okay, because we're looking for theta in radians. So x is 11 pi over 36 times the radius of 5. That's like 5 over 1. 11 times 5 is 55, so 55 pi over 36 inches. Boom. Shaka, laka. Here we go. Complement and supplement. I'm not going to be able to finish this in one minute. So what I'm going to do, I'm going to pause it here. Okay? I'm going to pause it here and continue 15, 16, 17, and 18 on the next video. See you then.